In the previous module, you learned that a hydraulic power pack, or HPP, is an assembly of components and controls that provide pressurized flow to hydraulic components. Now, we'll discuss each element of the HPP to know how they all fit and work together. In this module, you will determine the purpose of each hydraulic power pack HPP element. Learn the functions of each HPP element. The electric motor is a device that converts electrical energy to mechanical energy that's needed to operate the hydraulic pump. Most electric motors work by electromagnetism, but motors based on other electromechanical phenomena also exist. The basic principle behind electromagnetic motors is that there is a mechanical force on any current carrying wire contained within a magnetic field. Electric motors can be classified depending on their supplies. An alternating current, or AC motor, is an electric motor that is driven by an alternating current. A direct current, or DC motor, is designed to run on DC electric power. You now know that an electric motor is the driving means of the hydraulic pump. Now it's time to learn what the pump does. The hydraulic pump is the most important element in the hydraulic system. Its function is to transform mechanical energy of the motor into hydraulic power by pushing the fluid into the system. The pump must produce a flow and keep it constant despite the hydraulic resistance, whose intensity is given by the pressure. Pumps can either be categorized as hydrodynamic or non-positive displacement pumps, which are used in the transfer of fluids where the weight of the fluid itself and friction are the only resistance encountered. They are functionally dependent of the volume generated by the pressure, or hydrostatic or positive displacement pumps, which provide a given amount of fluid for every stroke, revolution, or cycle. They are well suited for use in transmission of power, since their output is independent of outlet pressure. The characteristic curve gives you a better understanding of these two pumps. In hydrodynamic pumps, if load requirement increases, the flow rate decreases. In hydrostatic pumps, if load requirement increases, the flow rate remains constant. Let's now discuss what the oil reservoir does. The oil reservoir serves as a container for fluid and protects it from environmental factors. Other functions of the oil reservoir are as follows. Holds enough fluid to adequately supply the hydraulic system. Provides a large enough surface to transfer heat from the fluid to the ambient environment by radiation and convection. Has enough volume to let returning fluid slow down from a high entrance velocity to allow heavier fluid contaminants to settle out. Provides space above the fluid for entrained air to escape to the atmosphere. For hot fluid expansion and gravity drain back from a system during shutdown. Removes used fluid and contaminants from the system and adds makeup and changeover fluid. Serves as a convenient surface to mount other system components if possible. Filters are a very important part of a hydraulic system. They provide adequate filtration of contaminants for better operability and longer service of the components in a hydraulic system. Filters may be positioned in a variety of locations. The types of filter installations are suction line filters, pressure line filters, and return line filters. Another important component in a hydraulic system is safety valves. Safety valves create a single direction of flow from the HPP to the hydraulic circuitry and protect the system when the filter becomes full. Filter contamination due to dirt creates greater pressure than what is needed to open the check valve. Check valves and pressure relief valves function as safety valves when used in an HPP. Check valves prevent some lines of a hydraulic circuit to be crossed by the oil in both directions. They are two-port valves, meaning they have two openings in the body, one opening for fluid to enter and the other for it to leave. Relief valves, on the other hand, act as a part of the control system. These valves control the pressure in a system by allowing the pressurized fluid to flow from an auxiliary passage out of the system. A hydraulic system builds up heat when running. That's why a cooling system is needed to prevent it from overheating. The cooling system dissipates the heat to the air or cools the oil, maintaining its temperature and viscosity. Removing the excess heat from the motor allows it to operate at its most efficient level. Most hydraulic systems have sensors that monitor the temperature of the liquid that passes through the system. There are two types of cooling systems: air-cooled, liquid-cooled. In this module, you've learned the functions of each element in an HPP. Electric motor converts electrical energy to mechanical energy that's needed to drive the hydraulic pump. Hydraulic pump transforms mechanical energy of the motor into hydraulic power. Oil reservoir stores the oil and protects it from environmental factors. Filters gets rid of contaminants in fluids. Cooling system removes excess heat from the hydraulic system.